Anyone who's ever worked with data knows that feeling, right? Just being completely overwhelmed. Well, today, we're going to pop open the Data Scientist Toolkit and show you the essential techniques for turning all that raw information into real actionable insight. So let's get into it. So just picture this for a second. You've got thousands, maybe millions of data points, customer reviews, patient records, sales figures, and you are just completely drowning in it all. So what's the plan? I mean, where do you even start? Look, the answer here isn't some single magic algorithm. It's all about having a well-organized toolkit and knowing exactly which tool to grab for which job. So come on, let's open it up and see what's inside. Okay, so let's pop open the first tray in our kit. This one is all about creating order from chaos. These are your go-to tools for sorting, for labeling, and for classifying all that messy data into neat, understandable groups. This is a perfect real-world problem. So a hospital has thousands of patient comments. Are people talking about billing or maybe staff courtesy, wait times? Trying to sort these by hand? Oh man, that would take weeks. And that's exactly where these classification tools really, really shine. So for a problem like that, you've got choices. Do you need a model that's really easy to explain to your colleagues? Something like logistic regression, which can tell you why a comment got flagged as negative? Or are you just after pure speed? Because if so, Naive Bayes is your go-to for just tearing through mountains of text. You see, the key takeaway is that you don't just pick a tool, you pick the right tool for the specific job and, the constraints you're working with. All right, let's snap that tray shut and move on to the second one. Now, we're not just sorting what we have, we're trying to predict what's going to happen next. This is where the real forecasting power starts to come in. And right away, we run into this classic kind of fundamental question in data science. Do you want a model that's incredibly accurate, but maybe a little bit of a black box? Or do you need a simpler model that's way easier to explain to everyone else in the room? This slide really lays out that trade-off perfectly. Over on one side, you've got lasso regression, a fantastic tool for simplicity. It's brilliant because it finds the few critical factors that truly matter, and it just cuts through all the noise. But on the other side, random forests, they go for pure predictive power. They basically build an army of models to get the most accurate answer possible, even if the why behind it is a little more complicated. Okay, tray number 3. Now this one is really special. It's all about tackling one of the trickiest kinds of data out there, human language. I mean, all that unstructured text in emails and reviews and doctor's notes, it holds a treasure trove of information, but only if you have the right tools to unlock it. The whole field is called natural language processing, or NLP for short. And you should think of it less like a single wrench and more like a whole section of the toolkit that's dedicated to making sense of human language. And right now, the biggest, baddest power tools in that section, those are the large language models, or LLMs. Let's be honest, these are the revolutionary engines that have completely changed the game for text analysis. And what they can do, I mean, it's honestly staggering, is you can see here, they can take a huge stack of documents and just summarize it instantly. They can read thousands of reviews and understand the sentiment. They can even pull out structured data, like names and dates, from messy, unstructured notes. This is a revolutionary leap for data analysis, no question. All right, we're at our final tray, and this one holds 2 very special kinds of tools. The first one helps you deal with just overwhelming complexity. And the second one, well, it gives you the raw power to find patterns that pretty much no other tool can see. Think about a patient satisfaction survey, for example. You don't want to analyze just 1 or 2 questions. You might have dozens, and the data can become incredibly wide, just really noisy. So imagine your boss drops a survey on your desk and asks for the key takeaway, and it has 60 different questions. It's almost impossible to see the forest for the trees. You really need a tool that simplifies things. This is where a technique like principal component analysis, or PCA, is an absolute lifesaver. It's what we call a dimensionality reduction tool. PCA is brilliant. It analyzes all 60 of those questions at once and finds the main ingredients in a complex recipe, combining all the related questions into just a handful of core themes. And boom, there's the magic. PCA can take those 60 noisy variables and just distill them down to the essential story. In this case, maybe it's just 3 things that truly matter to patients. Now that is an actionable insight. That's something you can actually do something with. And finally, for the toughest, most complex jobs, we've got the heavy machinery, neural networks.
These are the heavy-duty power tools of our kit, inspired by the structure of the human brain, and they're built to find incredibly subtle and complex patterns.
I mean, these are the models that are powering the most advanced AI out there. They can look at real-time vital signs and predict the risk of a life-threatening condition like sepsis. They're behind image recognition, speech-to-text, you name it. To put it simply, when the patterns in your data are just too complex and tangled up for any other tool in the kit, you reach for a neural network. So you see where this is going, right? This was never about finding one master key that opens every lock. The real skill of a data scientist is understanding the problem right in front of them and knowing exactly which tool from the kit is the right one for that specific job. And here it is, the whole shebang, a complete, balanced toolkit. You can see how each part is just essential. You might use classification tools to sort your data, then turn around and use prediction tools to forecast the future, all while using language models to understand the text buried inside of it. They all work together. So the only question left is, now that you've had a peek inside the toolkit, what problem are you going to solve first? Thanks for joining me on this tour.